Aeroengineering thermodynamics. Boiler. The boiler transfers heat to the incoming water and generates the steam. For this system, change in potential and kinetic energy are 0 and Work is also equal to 0 since neither any work is developed nor absorbed. Applying energy equation to the system, H1 plus Q equals H2. Centrifugal water pump. A centrifugal water pump draws water from a lower level and pumps to higher level. Work is required to run the pump, and this may be supplied from an external source such as an electric motor or a diesel engine. Here Q equals 0 and delta U equals 0 as there is no change in temperature of water. V1 equals V2 equals V. Applying the energy equation to the system, the sign of W is negative because work is done on the system or work enters the boundary. Schematic diagram of centrifugal water pump. 10 kilograms of fluid per minute goes through the reversible steady flow process. The properties of fluid at the inlet are: P1 equals 1.5 bar, 1 equals 26 kilograms / meter 3. C1 equals 110 meters /s and U1 equals 910 kilojoule /kilograms, and at the exit are P2 equals 5.5 bar, 2 equals 5.5 kilograms /meter 3. C2 equals 190 meters /s and U2 equals 710 kilojoule /kilograms. During the passage, the fluid rejects 55 kJ/s and rises through 55 meters. Determine by the change in enthalpy HII work done during the process W. Solution: flow of fluid equals 10 kg/minutes. Properties of fluid at the inlet. Pressure P1 equals 1.5 bar equals 1.5 105 m/meters to density. 1 equals 26 kilograms/meter 3 velocity. C1 equals 110 meters/s internal energy. U1 equals 910 kilojoule/kilograms. Properties of the fluid at the exit. Pressure P2 equals 5.5 bar equals 5.5 105 m/meters to density. 2 equals 5.5 kilograms/meter 3 velocity. C2 equals 190 meters/s internal energy. U2 equals 710 kilojoule/kilograms. Heat rejected by the fluid. Q equals 55 kJ/s. Rise is elevation of fluid equals 55 meters. In a gas turbine unit, the gases flowed through the turbine is 15 kg/s and the power developed by the turbine is 12,000 kilowatts. The enthalpies of gases at the inlet and outlet are 1260 kJ/kilograms and 400 kJ/kilograms respectively, and the velocity of gases at the inlet and outlet are 50 meters/s and 110 meters/s respectively. Calculate I the rate at which heat is rejected to the turbine, and II the area of the inlet pipe given that the specific volume of the gases at the inlet is 0.45 meter 3/kilograms. Solution: rate of flow of gases M equals 15 kilograms/s. Volume of gases at the inlet V equals 0.45 meter 3/kilograms. Power developed by the turbine P equals 12,000 kilowatts. Work done W equals 12,000. 15 equals 800 kilojoule/kilograms. Enthalpy of gases at the inlet H1 equals 1260 kilojoule/kilograms. Enthalpy of Gases at the outlet. H2 equals 400 kJ/kilograms. Velocity of gases at the inlet. C1 equals 50 meters/s. Velocity of gases at the outlet. C2 equals 110 meters/s. Air at a temperature of 20 degrees C passes through a heat exchanger at a velocity of 40 meters/s, where its temperature is raised to 820 degrees C. It then enters a turbine with same velocity of 40 meters/s and expands till the temperature falls to 620 degrees C. On leaving the turbine, the air is taken at a velocity of 55 meters/s to a nozzle where it expands until the temperature has fallen to 510 degrees C. If the airflow rate is 2.5 kilograms/s, calculate I rate of heat transfer to the air in the heat exchanger. II the power output from the turbine assuming no heat loss. II the velocity at exit from the nozzle, assuming no heat loss. Take the enthalpy of air as H equals CPT, where Ct is the specific heat equal to 1.005 kJ/kilograms degrees C and T the temperature